Good morning. Come to the next lecture video. Now problems on the stability of dams. So here the first problem, a trapezoidal masonry dam having 4-meter top width, 8-meter bottom width and a 12-meter high is retaining water up to a height of 10 meters as shown in the diagram. The density of masonry is 2000 kg per meter cube. The coefficient of friction between the dam and the soil is 0.55. The allowable compressive stress is 343,350 Newton per meter square. Check the stability of dam. Okay, they have given the dimensions and everything. Now we have to check the dam. You can see that the top width and the bottom width. So it is a trapezoidal thing with a vertical. So this is a typical diagram. So this has totally 10 meters of water height, 12 meters of dam height, 4 meters top width and 8 meters bottom width. The force, horizontal force, water force is F, the total weight force is W and the resultant force R. So here the given data are A equal to 4, B equal to 8, that is top and bottom width. The capital H is height of the dam, small h is height of the water. The density of the masonry is 2000. So weight density will be, so this is mass density, kg per meter cube should be converted into Newton per meter cube. So multiplying by g, that is acceleration due to gravity. Then coefficient of friction is 0.55, the symbol is mu. So first step we have to find out as usual the F value, that is force due to water, that is W into A into H bar. So it is 1000 into 9.81, that is will be total W or 9810. Then area is 10 into 1. So 1 is nothing but length, that is unit length. Then 10 is the height of the water. So height of the water divided by 2. So totally 490,500 Newton. Then the total force is acting at the height of 10 by 3 from the base. Then weight of the dam, that is capital W, we have to find out. So for that, weight density of the masonry into volume of the dam. So volume is nothing but area into length 1. So area is A plus B by 2 into H into 1. So W naught is weight density. So substituting 2000 into 9.81. So 4 plus 8 by 2 into 12 into 1. So it is 141,260 Newton. So this is the total weight. So then we have to find out the AN distance. So AN distance, here you can see that it is given through the CG formula, or else directly the CG formula for the trapezoidal with the vertical face is A square plus AB plus B square divided by 3 into A plus B. You can also substitute there and find out the AN distance, which will be equal to 3.11 meters. Then first check is to find, we have to find out the x distance. X is nothing but F by W. X is equal to F by W into H by 3. So substituting in that, we can find out the x distance. Then AM, that is D value, is equal to AN plus X, which will be equal to 4.267. So we have found out all the dimensions. Now the check. The first check is to find out the check for tension. Check for tension. So for the tension, the D star, that is nothing but the B value should be, the eccentricity should be equal to, so the AM is eccentricity. So eccentricity should be equal to B by 6. So here the B value is here the B value is 8 meters. So 8 by 6, that is the eccentricity value 4.26. It should be less than or equal to the D, that is this value D star should be less than or equal to 2 by 3/3 of the total width. So it is 5.33 meters, and hence AM is, that is 4.2 is less than 5.33, and hence the dam is safe against the tension. Then check for overturning. You have to check that the resultant should pass between the base. That is, in the diagram, the resultant should be before b value, that is x distance should be less than the nb distance, here x value is much lesser, here the x value is much lesser value. So the total x value here is only 1.157. The total width is 8 meters. So hence it is safe against the overturning. Then check for sliding. So sliding, the F max should be equal to mu into W. So which is equal to 0.55 into W1412640. It is 776952. But the force is 490,500, which is less than the F max, so it is safe against the sliding. Then finally, for the stress, maximum compressive stress, you have to find out the sigma from W by B into 1 plus 6E by B. So here B is equal to D minus B by 2, which is equal to 0.267. So substituting this E value, the total sigma value should be, less than the allowable stress. In the question it is given the allowable stress, so that value should be, that is allowable, the calculated this stress must be less than the given stress in the question. So with this, all the things are against safe. So this is a standard procedure, that is you have to check for tension, overturning, sliding, and then check for excessive compressive stress. So thank you. So these are the problems you have to do based on the stability of dams. Thank you.